Hi everyone, it's Mrs Abbas here. I thought we could do a little bit of maths focused on place value to begin with. So today we are going to be looking to see if we can order and compare numbers in a range of contexts. And to achieve that learning question, we're going to be able to order and compare a range of numbers below 10 million in different contexts. So that might be whole numbers, it might be decimal numbers. You'll be able to use your knowledge of place value to identify, compare and order decimal numbers, and then be able to apply your knowledge of place value to explain and reason how you have ordered and compared numbers, so that justification behind exactly why you have done something. So, to begin with, I want you to just have a look at the numbers that are on the board. How would you say these numbers? So if we have a look at this first one here, I can see I've got my ones, tens, hundreds, thousands, 10,000s, 100,000s, which makes this number here, this digit here, a million. Okay, so we've got 1,239,208. Let's have a look at this number here because that is slightly different. We've got our ones, our tens and our hundreds, our thousands, 10,000s, 100,000s. Then we have got our millions. Now this is obviously slightly different to this one here. We had 1 million here. Here we've got 129,208,176. Now what I want you to do is just maybe pause the video and see if maybe with a parent or a carer or sibling that you've got home, if you can have a go at reading some of the numbers that are on the board. Okay, so now I want you to have a look at what would happen if we changed some of the values of these numbers. So if we increase them by 100, for example. So let's choose this number here. If I am increasing this number here by 100, what does that mean? Well, it means that the number is going to increase. We're going to add 100 to it. Now, I won't be adding 100 to my ones. I won't be adding 100 to my tens. I will be adding it to my hundreds column here. So the only change here will be that this 0 will become 100. And if we were to say that number, we would have 12,789,104. What would happen if we added 200, 300? Well, each time this digit would change. The ones and the tens would not change because in multiples of 100 there is no value to the ones and to the tens. So after looking at reading some of those numbers, how do you think we could go about ordering these numbers? What will I need to do to be successful? What will the first thing be that you need to do? Because at the moment, I've got some of my numbers written in words, some of my numbers written in digits. So the first thing I would do is that would make sure that they are all the same. It will make it a lot easier for me. So I'm going to write my words that are currently in numbers into digits. So I've got 712,480. Okay, and then I've got B, which is written already as digits for me, and then C, so I've got 709,000, so no 10,000s, 921. Okay, so that should then make it easier for me to order my numbers. Now I could order them from smallest to largest, I could order them largest to smallest. So if I were looking for the smallest number here, it cannot be this number because we have our thousands, 10,000s, 100,000s, the same with this one, the same with this one. But here, I've got a number that does not have any 100,000s, so that will be my smallest number. 71,208. So I can effectively cross that one out because I've used that number now. And to make it easier, I can visually cross it out with my line tool. Okay, so the next number we have, so we've got 712,480, 712,135. We have our number that was written in words, which we've rewritten, 709,921, or 752,801. Now, all of these numbers have got 700,000s, so we will not be looking at this digit. So let's go to our 10,000s. Well, this has 1 10,000, this has 1 10,000, this has 0 10,000s, and this has 5 10,000s. So the number that would come next in my order would be 709,921. And again, I can cross that number out to make it really clear that I have used that number already. And I will also cross it out up here. So I've got 3 numbers left. I have 712,480, which we've rewritten here in digits, 712,135, and 752,801. Now, if I look at these 2 numbers here, A and B, they have the same amount of 100,000s, same amount of 10,000s, and the same amount of 1,000s. So the digit that I need to look at next will be the hundreds digit. In this number here, it has 4 hundreds. In this number here, it has 100. So the number next in my order would be 712,135. Again, let's just cross that out and make it really, really visual for us to say that we've used that number. 2 numbers left. Now it must come next in my order, 712,000, as we've got here, 480. So 712,480, which must mean this last number here, A, is the largest number, 752,801. What I want you to do now, and you can pause the video if you would like to, is I would like to have a go at ordering the numbers that I am writing here. I wonder if you could order them from largest to smallest. So you can pause the video and have a go at doing that, maybe on a piece of paper, maybe on your own iPad or laptop, however it is that you are choosing to watch this video. So can you order these numbers here from largest to smallest? Now, once you've had a go at practicing ordering those numbers from largest to smallest, I've given you another example here. Now, I'm giving you the opportunity to choose how you're going to order your numbers, so you can either order them from smallest to largest or largest to smallest. However, I have made it a little bit trickier for you, because you can see we've got numbers that are written in digits, numbers that are written in words. So think about what we just modelled, what will be the first step that you take in ordering these numbers. So it will be to write them out all in digits or all in words, whichever you would find easiest. I would find writing it in digits easier. And then it will be identifying the place value of those numbers. So looking at the value of the digit that is in the millions column, for example, in these numbers, which number would come first if you're ordering from smallest to largest or largest to smallest. Now we're going to move on that a little bit more, because in our success criteria we talked about ordering decimal numbers, and we are using the same method. We are using our place value knowledge. So we can see here with these numbers, each of these numbers has 3 wholes. We've got 3.41. So we have 3 wholes, 4 tenths, and 1 hundredth. Now, you know I always talk about making sure that the decimal place is in the right place. So when we are looking at comparing decimal numbers, it's very important that we keep the decimal point, in the same place to make it easy for us. So we have the next number, 3.04. And with us keeping that decimal point in the exact same place, it means that we can compare these tenths and these hundredths a lot easier. So what I'm going to do is I'm just going to write these in a list to help us order them. I then have 3.4, 3.44, and then we get to the whole number 3. Now what have we, think about what we have talked about in class. 3.00. Just because it is a whole number does not mean that we wouldn't put any digits after the decimal point. It just means it's a whole number, it has no tenths, it has no hundredths. But when comparing them, it makes much more sense to have the same amount of digits after the decimal place, so we can put our zeros, our placeholders in. So when looking at these numbers now, which one would be the smallest number? Well, they've all got 3 holes, so we move to the tenths column. Now, I've got 3.04 and I've got 3.00. So my smallest number, because this number has no hundredths, whereas this number does, would be 3.00 or 3 in that case. So I can cross that out, I've used it, make it really visual again. So we'd already identified that this number here had no tenths, had 0 tenths. So that will be our next number in the order, 3.04. And again, cross it out. Now it becomes a little bit more trickier because we have got 3 numbers who have the same amount of holes, or ones, the same amount of tenths, but a different amount of hundredths. So here we have 1/100th. Here there is not a digit. So think back to our learning from when we've been in class. What could we put there to represent how many hundredths there are? We could put a 0 to represent that there are no hundredths. So the number that would come next in my order would be 3.40. Cross it out again so I know that I've used it. And I am left with 2 numbers, 3.41 and 3.44. So 3.41 because it has 4 tenths, 1/100th. And my last number, 3.44, because it has 4 tenths and 4/100ths. So I've ordered my decimal numbers from smallest to largest. What I want you to have a go at now is to see if you can have a go at ordering some of these numbers. Now, this isn't a problem-solving way because I want you to apply what we've just done. So ordering the numbers, the decimal numbers, and the whole numbers from smallest to largest. However, this has been done so that you can explain what mistake these people have made. So Rachel orders a set of decimal numbers. There they are in purple. But John says that Rachel is wrong because 2.5 is in the wrong place. Rachel says she is correct because 2.45 has more digits after the decimal place than 2.5. Can you explain why she is wrong? So use that place value knowledge to justify and to explain. Have fun!